let's define a string called long string. Let's say that I want to print out the first 4 characters. How I would do it is 0 for the 0 index, and then 4. It's not going to print out the 4th index. And you can see owl pops up. If I want to print the last 5 characters, something a little bit weird here we can do. I'm going to put -5, colon, and then nothing at the end of it. You can see floor shows up. And if I also wanted to print out everything up to the last 5 characters, I'm going to do something very similar again. Long string, except in this situation I'm going to put a colon, no number in the front, and -5 again. There you go. You can concatenate or join 2 strings together using a substring, long string, and we could do something like :4 plus be there. There it goes, I'll be there. And another way to handle formatting with strings using the print command is, let's say that I want to output a character. I'm going to put a % and a C is my, here I'm going to have a string show up, letter, and my number. If I wanted to put a signed integer, I'd put % and D. Number is, and here I'm going to say that I want to use a floating point number or a number with a decimal place, and I want to make sure that it has at least 5 decimal places. Put % down here at the bottom, and then we're going to put in all of our input. So let's say that I want to say that X is my favorite character, and for the string I'm going to have to put favorite inside of there, and number 1, favorite number, is going to be 0.14. Whoops, and make sure you put your brackets around this, and then the closing bracket. And you can see right there what it did is X is my favorite letter, and my number 1 number is 0.14. And you can see, because I put the 5 there, that it prints out 5 decimal places even though it didn't exist previous. Another thing we can do, get rid of this, is if we wanted to capitalize the first letter of a string, let's go long string and capitalize, and there it is. If we want to return the index value of the start of a string, we could do something like print long string find, and if the word we're looking for is floor, type that in. You can see that's the 33rd character right there. Just make sure that this is case sensitive, so this has to be exactly the same. If we want to return true if all the characters that have been entered in a string are all letters, we go long string is alpha. If we want to make sure that everything's a number, is all num. We could also come in and get the length of our string, long string, and we could come in and replace a specific word with another word, long string, replace. Say we want to replace the word floor with the word ground. There you go, see, floor became ground. And something else that's useful is if we want to strip white space. There's no white space in this situation, but if there was, we just type in strip. And then if we wanted to split a string into a list, go long string and split. And then what we would put inside of here is how we want those words to be separated, which a space works out great there, and quote list. And there you can see it took that string and converted it into a nice list. So that's mainly what you're going to want to do with strings inside of Python. Now let's look at file I/O, or input output. If you want to create as well as open a file, I'm going to call this test file. You're just going to call open, and I'm going to give it a name. I'm going to call this test.txt. And if I want to be able to write to this file, I'm going to send WB as my command. I could then output on the screen the file mode that was being used. In this situation, it's going to be WB by just going test file and mode. If I forgot it for some reason and I wanted my file's name, I could just type in name and it's going to print that. And then if I want to write text to a screen or to a file, I'm just going to go mention test file, write. And it's a little bit odd. You're going to have to type in bytes. And then you're going to type in write me to the file, put new line inside of there. Then after this, you're going to have to type in UTF-8. About the only odd thing we've seen so far with Python. And then finally, if you want to close a file, you just type in close. And there you can see WB and test text prints out on the screen. But you may be asking yourself, well, how do we read information from a file? Well, since we closed the file, we're going to reopen it. Equal to open. We have to tell it which one of those we want to open. Test text, and make sure you type open. And then we're going to tell it the mode here. Here we want to open it for reading and writing, and make sure you put this inside of quotes. And reading and writing inside of quotes is R+. We could go text in file and read that data out of there. And how we do that is test file and then call read. And then finally, if we want to print that out on our screen, text in file, write me to the file shows up over here. If we then want to delete that file, say we don't expect to use it anymore, this is where the OS module comes in. We just call remove and then tell it the name of the file we want to delete, and it'll delete it. Alright, so that's the major stuff you need to know for file I/O. Now let's take a look at objects. Now the concept of object-oriented programming allows us to model real-world things using code. So just like every real-world object has attributes like color, height, weight, and every real-world object has abilities like walk, talk, and eat, we're going to define attributes using variables inside of things called classes, and the abilities are just going to be functions. Now how you define these real-world objects is you use a class, which is a blueprint for creating animals in this situation. Now let's say we want to create our attributes, such as name, and none signifies a lack of a value. You can have it be whatever you want. You can put none inside of here, or you could have just simple quotes, whatever. I'll use either. We're then going to say that our animals are all going to have a height, weight, and then it's going to have a sound. Now, by preceding these variables with 2 underscores, what I'm saying is these are going to be private. And what that means is if we want to change the values here, we're going to need to use a function inside of the class that's going to allow us to change it. And if we want to get those values, we're also going to need to use a function inside of the class. So for example, if we want to set the name, we're going to do, just like every other function, we're going to type in def for define, and here I'm going to say set name. Self automatically pops inside of there, and what self means is it allows an object to refer to itself inside of the class. So for example, when I create this class animal, well, no animals exist out in the real world. So if I want to refer to an animal object, I need a way to do it, and self provides that way. So I'm saying I want to change the object's self. Kind of bad English, but that's what I'm going to use. So if I want to set the name, I'm just going to come in here, and a name is going to be passed inside of here. Then I'm going to say if I want to change the specific name, I'm going to type in self, 2 underscores, and name is equal to whatever the name is they passed inside of it. Likewise, if they want to get the name, they're going to have to use this function once again because the name is private because it has 2 underscores there. Get name, and then in this situation, I will just return self dot underscore name. And we're going to do that for everything, and this is called encapsulation, and it just basically allows us to say, hey, is the name they passed in here valid? And if it is, then we'll set it. I don't have any of that in here, but we could use something like, is it all characters? And if they typed in a number, we could say, nah, we don't like that. We demand that you enter all characters for the name, otherwise we're not going to set it. Okay, so that's what we're doing. We're verifying that the data is good. Another thing you have inside of classes are things called a constructor. And basically a constructor is going to be called to set up or initialize an object. So we're going to say define, and the constructor is 2 underscores, init, like that, and then 2 more underscores. Now in this situation, whenever an object is created, we're going to demand that all the values be passed in here. So we're going to say that we want the name to be passed in, the height to be passed in, the weight to be passed in, and a sound to be passed in. Then, whenever those things are passed in, we're going to say that we want them to be changed or defined. So, name, the sound that was passed in. See, I'm initializing, I'm setting up those objects. Now what I'm going to do is I'm going to create setters and getters for all of these different guys. And there you can see setters and getters for every single one of these different variables we have defined inside of here. And another thing I'm going to do here, this is going to be used so I can demonstrate polymorphism. I'm going to have get type, which is going to print out the object name, so, or the class name. So it's going to be animal. Put it inside of quotes, of course. Another thing we can do is, let's say that I want to print out all of this information to the screen. Let's just create a 2 string here, self, and let's say I want to return. Another way of formatting output inside of Python is to use these curly braces like this to represent where you want information to go. So I could say blank is, that's going to be the name, and then I could have how tall the animal is and the weight of the animal, and says whatever the sound is for the animal. I could then follow this up with format, another way to work with these guys. And then if I want to refer, since I'm inside of the class, I don't need to use the setters and getters to refer to the values of these variables. So I could have self dot 2 underscores and name. And let's jump down to the next line. And I could go self dot underscore height underscore weight underscore sound. So those are all of the different functions and attributes I'm going to define inside of this class. Now let's go and take a look at exactly what this is going to look like as an object. I'm going to come down here, and the very first thing I'm going to create a object called cat, which is of type animal. And if I want to call the constructor, I'm going to pass the name Whiskers, and let's say that he is 33 centimeters tall, 10 kilograms in weight, and he likes to say meow. Well, now that object is created, and I can treat it like it is a regular old cat. I could also come in here and go print and cat and toString. Let's come back up here, figure out what I did wrong. Oh, that's what I did wrong, is equal to the sound that was passed in. No big deal, we all make errors. And now let's check it again. There we go, Whiskers 33 centimeters tall, 10 kilograms, and says meow. See? Now we're going to go over something called inheritance. And all inheritance means is whenever you inherit from another class, that you're automatically going to get all the variables and methods or functions that are created in the class you're inheriting from. So let's say I want to create a class called dog, and I want to inherit from the animal class. That's all I need to do, right like that. And I automatically get every variable and every function that's already in the animal class. Then let's say I want to come in here and give it a name like owner. There we go. So every dog but not animal is going to have an owner. I can then overwrite the constructor for the animal class. Let's say I want to do something more specific here since it's a dog. Let's say that I'm still going to be able to, or still require them to enter a name, a height, a weight, a sound, but now I also require them to enter a owner name. Well, to set the owner, just like before, we type in self, 2 underscores, and owner, and make it equal to the owner value they passed in. So what happens if I want the name, height, and weight, and sound to be handled by the animal superclasses constructor up here? Well, pretty simple. I'm just going to type in super. It's the superclass. It's the class above. I'm going to type in dog, and then I'm going to type in self, and then I'm going to follow that by 2 underscores, init, and then I'm going to pass in the name, the height, the weight, and the sound. Another thing I need to do is allow them to set the owner. So set owner, and owner is going to be passed in here, of course. And then I just go self, owner is equal to the owner value they passed in. Also want to do the same thing to get the owner. Just do return self dot owner. And then I could also come in here and define get type, like I said before. In a second you're going to see what this is for. Self, and have it just print that we are using a dog object. We can also come in here and override functions on our superclass by, let's go and say that we want to change the toString. If we just create a new function with a name that's already in the superclass, that's called overriding it. And might as well just come up here and just take this whole thing, paste that in there, and then let's just say here at the end we say something like his owner is, and then we put our brackets in there just like we did before, and then at the very end of this, self dot 2 underscores and an owner, and make sure you put that other comma in there. And while we're working at this, might as well cover method overloading. Basically what method overloading means is that you'll be able to perform different tasks based off of the attributes that are sent in. So let's say that I wanted to create a function here in multiple sounds like this, and I want them to have the option to send in how many times we want our dog to bark, for example. So here's an attribute, but we're going to set this to the value of none. That means that it's going to be okay for them not to send in a value for how many. Then what we'll be able to do is come in here and say if how many is none, well then we'll just say print and self and get sound like that. Else, if they passed in a value, don't need that extra guy there. Else, if how many was passed in, then what we're going to be able to do is go else, print, and self again, get sound, and print it out how many times they say they wanted it printed out. So there's how many. Okay, so that's a way of getting around method overloading. This is just one way of saying that we do not require attributes to be sent into our function. Alright, so now that we did all that stuff with our dog, let's create ourselves a dog object. And let's call him Spot and dog. And like I said, he has the name Spot, 53 centimeters tall, 27 kilograms weight. Let's say his sound is rough, and let's say that I am the owner. There we go. We could come in here and print Spot toString, and you can see over here Spot is 53 centimeters tall, 27 kilograms, says rough, and his owner is Derek. And then the final thing I'm going to talk about here is called polymorphism. Now, polymorphism sounds really complicated, but it basically just allows you to refer to objects as their superclass and then automatically have the correct functions called automatically. And an example will probably explain it better than what I just said. So let's say we create a class called animal testing. And inside of it, we're going to create a function called getType, and it is going to receive animal objects. Then what it's going to do is it's going to refer to animal and getType. So getType, make sure that I put it inside of here. Yeah, there's getType. Here it returns that it's a dog object. And up here, getType returns that it's an animal object. Now we're going to create a test animals object of type animal testing. And you're going to see that if I go test animals dot get type and pass in a cat object, which is actually an animal object, and test animals dot get type and pass in a dog object, which is named Spot. And if I save this and run it, in this situation, the cat is an animal object. It prints out animal, and in this situation, it prints out dog. All right, so that's just a way I pass in a cat, which is of type animal, and it automatically knows to go and call this version of getType. And in the other situation, I pass in a dog object, and it automatically knows to go and print the dog version of getType. So that's a brief explanation of polymorphism. And then the final thing, remember I said up here multiple sounds, and we don't need to necessarily pass in how many. In this situation, I'll show how that works. Multiple sounds, and I'll pass in 4 once, and then the second time I will pass in nothing. And there you can see, rough. Right, guys, so there's a rundown of the Python programming language. Covered as much as I could. Hope you guys enjoyed this, and please leave your questions and comments below. Otherwise, till next time.